This is the syllabus of this chapter, what all things are included in that. Okay, this is the shape of a nucleus. So, or an atom. This is the nucleus, and these are electrons going around in the atom. Inside the nucleus, you have protons, you have neutrons. So the number of protons is denoted by letter Z. Number of protons plus number of neutrons is denoted by letter A. That is called as mass number. This is atomic number. Okay, and for a stable nuclei or a stable atom, the number of protons and number of electrons are equal. Now here, for an isotope, isotones and isobar, this is again something that you know from before. You should know the meaning, and you should know examples. So what is an isotope? Isotope is the same substance, but they have different mass number. So this is a carbon isotope, carbon 12, carbon 13. Carbon 12 being the most abundant atom in the world. Then you have isotones. In isotones, the difference between mass number and atomic number is same. Like here, 23 minus 11 and 24 minus 12 is equal. And isobar are different substances, okay, but they have the same mass number. So here you can see 23 and 23. After this, what we are coming to is radioactivity. So in radioactivity, what I'm giving you an example of a non-radioactive atom. So where the number of protons and number of neutrons are almost equal, but in the case of an atom which is radioactive, the number of neutrons upon number of proton, the number exceeds 1.5. Okay, now because of this disparity, that atom is radioactive.
So can you repeat this part again? I didn't get it.
Yeah. So what is the meaning that an atom is radioactive, or it is called as unstable? Okay, that in an atom where the number of neutrons are far more than the number of protons, like the number of neutrons divided by the number of protons, the number is more than 1.5. Now this is an indicator that an atom is not stable or the atom is radioactive. Is that clear to you?
Yes, I got it. Thank you.
Okay. Now, if it is radioactive, what does it do? It gives out radiation. Okay. Now, which radiation? So those are alpha, beta, and gamma. So these radiations are given out from the nucleus. Okay. These radiations are given out from the nucleus of an unstable atom. Okay, like uranium will be giving out this alpha, beta, gamma radiation. Okay, now why do they give out these radiations? To attain stability. Are you understanding that? Okay, to become stable. Now, what is the meaning of becoming stable? The meaning of becoming stable is that inside the nucleus, the number of protons and number of neutrons must be almost equal, or the ratio should be less than 1.5. Is that clear to everyone? Any questions so far? Okay, Harsh, are you listening?
Yes, sir.
Yeah. So the atom is said to be radioactive when the number of neutron exceeds the number of protons by a big number. And when it is radioactive, what do you mean by that? It gives out these radiations. Why do they give out these radiations? Because it wants to become stable. Okay. Now the next question is, what affects these radiation or affect this rate of radiation? Okay. Will physical change or chemical change affect? Okay, what is the answer to that? The answer is no. There will be no change in the rate of radiation. Okay, I'll tell you why. Now, students, what do you mean by chemical change or physical change? Physical change when a substance is becoming a solid or a liquid, you're heating it, melting it. These are physical change. Chemical change when like you are oxidizing a substance, like if you are making uranium into uranium oxide or something. So when you do that, does that affect the radiation? The answer is no. Have you understood this? That physical change or chemical change will not affect the radiation. But the question is, why will it not affect? Because radiation is a nuclear phenomena. Okay, radiation is a nuclear phenomena. Now, what do you mean by that? See, all the radiation, alpha, beta, gamma radiation, all are given out from the nucleus. Okay, and nucleus does not take part in any of the physical change or chemical change. That is the reason why the rate of radiation remains unaffected even if there is a physical change or chemical change in the radioactive substance. Any
So can you
questions?
repeat this part? So can you repeat this part?
What have you not understood?
So the part where because it is a nuclear phenomenon. So that part.
Yeah.
So
So
I
I'm
want
saying,
it.
yeah, I'm saying that when there is a physical change, that means the shape and size of the substance changes. The substance melts. From solid it becomes a liquid. From liquid it becomes a solid. This is physical change. Chemical change. How does chemical change take place? By either sharing electrons or either donating electron or accepting electrons. So what I'm saying is a physical change or a chemical change is not affected by means it does not affect the nucleus. And these radiation are given out from the nucleus. And that is the reason why the rate at which alpha, beta, gamma radiation is given out will not change, even if there is a physical change or a chemical change in the radioactive substance.
Okay, so got it. Thank you.
Okay, fine. Now moving ahead, let's go back and see what the this thing is showing you. Okay, so we have seen what is radioactivity, what is the radioactive substance. Now radioactive substance give out alpha, beta, gamma. I told you already. Now this word which is over here, that it is spontaneous. Okay, and another word is disintegration. So remember this, the nucleus of an atom gives out alpha, gives out beta, and gives out gamma. Okay, now when will alpha be given out, when will gamma be given out, or when will beta will be given out? You cannot predict. Are you getting it? You will not know. You cannot predict. Now alpha will be given out. Now beta will be given out. Nobody can predict it. That is the reason why it is called as spontaneous. Is that clear to you? It is called as spontaneous because you cannot predict the emission of alpha, beta, or gamma. It's based on probability. Next is disintegration. Now we will study in this part now, okay, the nature and properties of alpha, beta, and gamma. Then you will understand disintegration. Okay, imagine a nucleus to be something like a, like a mithai or something. Okay, it's like a sweet. Now you are cutting a portion of it. You are cutting a portion of it, and that portion is emitted as alpha. Then you are cutting another portion of it, and that is emitted as beta. So that is the reason why it is called as disintegration. It is disintegrating, becoming smaller. Do you follow that? So radioactive emission, yeah.
So what is the cause of disintegration?
So here I had written it, right? Why do they give out these radiations? Because they want to attain stability. And why are they radiating? Because they are unstable. The ratio of neutron to proton is high. That is the cause of disintegration. Is it clear to you?
So
Yes, sir.
disintegration is yes, actually I got it. Sorry.
Okay, now moving ahead, we are going to study when one alpha particle is given out, when one beta particle is given out, what happens is what we are going to study. Okay, so this is a substance, a radioactive substance. Okay, just a minute. Yeah, this is A and this is Z. Now, when it gives out a beta particle, sorry, an alpha particle, the atomic mass number reduces by 4 and atomic number reduces by 2. So this is a very simple chemical equation that you need to remember, that when an alpha particle is given out, this is an alpha particle, the atomic mass number reduces by 4 and atomic number reduces by 2. So let's take an example. This is uranium 235 and 92. When it gives out an alpha particle, this will become 231 and this will become 90. Any questions? Okay, so an alpha particle is nothing but it's like a helium nucleus. Okay, a helium nuclei will have 2 protons and 2 neutrons in it. And that's what the alpha particle has. Now we will see.
The alpha particle is helium, right?
Yeah, it's a helium nuclei, but remember, it is given out from the nucleus of uranium or any other radioactive substance. So basically, if you talk about these are protons, okay, and these are neutrons inside a nucleus. Okay, so this is a nucleus. Now from that nucleus, if 2 neutrons and 2 protons escape, we say that the nucleus has emitted an alpha particle. Is that clear to everyone? Okay. Now this is Z plus 1. This is energy. Now when a
Z plus 1.
Yeah, when a beta particle is given out, the atomic number increases by 1. When a beta particle is given out, atomic number increases by 1. Okay. So like I told you, this is a neutron. So the neutron turns into a proton plus an electron. So when a beta particle is given out from the nucleus, okay, there is one increase of proton in the nucleus. So inside the nucleus, if you have a neutron, what will the neutron do? The neutron will convert itself to a proton and release an electron. This is beta emission.
I didn't get this part.
In a beta particle, when a nucleus emits a beta particle, Z becomes Z plus 1. So for example, uranium is 235 and 92. Then it will become 235 and 93. Do you follow that now?
Yes.
Okay, you need to remember only that much. So this is beta emission.
So I didn't get the part of the converting of that into an electron. And
that is the logic. That is the logic over here. What is the charge on neutron? What is the charge on neutron?
So charge on neutron is so I don't remember.
Anyone else?
Is it no electric charge? Does it have does it have normal charge?
There is no charge.
There is neutral, right?
There is no charge. What is the charge on proton?
Positive.
Positive.
What is the charge on electron?
Negative.
So what was the charge before? No charge. What is the charge afterward? No charge. Because positive and negative will cancel each other, right?
Yes, sir.
That's what happens inside the nucleus. So when a beta particle is given out, there will be an emission of electron from the nucleus. And inside the nucleus, there will be one proton more now. That's why it is Z plus 1. Okay. Now, when a gamma is given out, there is no change. So gamma particle is nothing but excess energy, which we have seen in the chapter spectrum as well. Okay, so there is no change. This asterisk indicate that it is in an excited state. It has more energy. So that extra energy is given out in the form of gamma radiation. Fine. So what I have shown you just now, okay, is the changes in the nucleus, changes within the nucleus when there is alpha beta decay equations. Are you getting it? When an alpha beta is given out, what is the change that happens? That is what I have told you. Any questions?
No, sir.
So in the alpha particle,
Yeah.
so the protons and neutrons are given out, but are electrons also given out?
In an alpha particle, no. That is the reason why I called it as a helium nuclei, not a helium atom.
Okay, sir.
Okay. Now, moving ahead, we will do some simple thing with the help of to understand that equations. Okay. But before we move ahead, we should know the properties of alpha, beta, and gamma. The properties are following. I've given you that in the notes as well. Okay, so this is what is there in the notes. So what is an alpha particle? It is positively charged and it is a helium nuclei. Okay, what is a beta particle? It is energetic electron. What is gamma? It is an electromagnetic radiation. Okay, this you don't need to know. Even if you don't know it, that's fine. But what you must know is the following. That is this. Because you know that gamma is electromagnetic radiation. And electromagnetic radiation travels with this speed in vacuum. So you're expected to know that. Okay. Moving ahead. What is a charge? Now see, alpha particle had it had two protons. So 1.6 into 10 to the power minus 19 into 2 will give you this much plus. Okay. This is an electron. So therefore it will be negative 1.6 into 10 to the power minus 19. And gamma is electromagnetic radiation. It has no charge. So this.
So in the second column, why is it what happened to the into 2?
What happens to?
What happens to the into 2? So for proton, you said that it will be 1.6 into 10 into 2. So
Yeah.
in the other, what happens to the 2?
What happens to the 2 means 1.6 into 2 is 3.2, no?
Yes, sir.
So what was your question?
So my question was, shouldn't it be the same for electrons except for in negative?
No, this is 2. Why it is 2? Because we have studied here that when you talk about the alpha particle, just a minute. In an alpha particle, there are 2 protons, no? But
Yes.
here it is only 1 electron.
Oh, okay. Yes, so got it.
Okay, so that's why it is 1.
Okay, so yes, thank you.
Okay, next is effect of electric field and magnetic field. So alpha particle is deflected, but it is less deflected because it is heavy. Here it is deflects more because it is electron and electron is very light. The reason why they are deflected because this is positive, this is negative, and if there is an electric field like positive, so alpha particle will definitely move toward the negative. Beta particle will definitely move toward the positive. This is unaffected because electromagnetic waves are unaffected by electric and magnetic field. That is what you had studied in chapter spectrum. Okay.
So,
Yes.
so can you explain it again? So why do they deflect?
Alpha particle is positive Beta particle is electron, which is negative. Therefore, when they enter the electric field, if a positive charge will enter the electric field, the positive charge will move toward the negative. If a negative charge will enter the electric field, it will move toward the positive. That is called as deflection. Do you understand that?
Yes, sir.
Okay. Does anyone know the meaning of ionizing power? What is the meaning of ionizing?
So is it when you form ions from a polar covalent compound?
And how do you form ions?
So by dissolving them in water.
No. Okay. If you have an atom which has electrons which are going around like this, and when you have alpha particle hitting it, it will dislodge the electron. Are you getting it? So when this electron is dislodged, this becomes an ion. Okay. So alpha particle being heavy, maximum ionization takes place. Beta particle being a tiny electron, it does very less ionization, and gamma does very, very less. Okay. So how will this question be asked? The question will be asked, arrange in the increasing order of ionizing. So it will be alpha, beta, gamma. Is that clear to you? Alpha ionizes the most, beta less, and then gamma. So all these questions which are there, they will be all, you have to arrange it either in an increasing order or in a decreasing order. Now, penetrating power. Alpha can penetrate in air very less. Beta also can travel few meters, but gamma can travel few hundred meters. Okay. So therefore, again, penetrating power, it is this way. To stop it, human skin or paper can stop alpha. 1 millimeters of lead or 5 millimeters of aluminium can stop beta. But you can see that 30 centimeter thick iron or few meters of concrete, like the pillars of the metro, they can block gamma. So if you have a metro pillar and you have gamma radiation entering, there are chances that it will pass through that as well. Okay. So therefore, this you should know. The biological damage, of course, immense damage. It can cause cancer. This causes a little less damage, and the least is caused by alpha. Alpha causes the least damage. Any questions so far?
No, sir.
Okay.
Yes.
So students, this is, these are the nature and the properties of alpha, beta, gamma. Okay. The meeting will get over. Please join back. Okay. So now we have the next part, that is use of radioactive isotope. Okay. So radioactive isotope uses. This is also very important. Now, there are 3 types of uses in the radioactive isotope, which is given in the notes. Okay, so the first is medicinal use. Students, remember, you can't just say it is used to cure cancer. You have to say radiation from cobalt-60 is used to treat cancer. That means the example has to be there, the name has to be there. Okay, so medicinal use, these are the few I have mentioned. You are expected to learn them. Next is scientific use. So alpha particles are used as projectile for nuclear reactions. Okay, the part which is cancelled for you, like a nuclear reaction which happens in a nuclear power station, you need neutrons, and they are formed by alpha particles. So another scientific use is it is used in agricultural science, where along with the fertilizer, radioactive tracers are given. Okay, radioactive tracers. Like for example, Have you heard about this CT scan? Has
Yes, sir.
anyone-
Yes, sir.
Yeah. So what happens is when a person has to be taken for a CT scan, they inject a fluid in that person. That fluid will have these radioactive tracers. So when that goes into your blood, and then you are in that chamber, where they like this is the chamber. So there is a magnetic field created over there, and this magnetic field uh, will trace these tracers that goes and feed to a computer, and an image is created. So a CT scan is performed of either the whole body or the brain or something. Okay. Then this is age of rocks. The process is called as carbon dating. So whenever we are living bodies have a certain proportion of carbon 14 in our body. So when the person dies, this proportion is starts getting reduced. So when people found fossils, they calculated the amount of carbon 14 left in their body or in the bones. So they estimated the life of that person or life of that fossil. You don't need to know the detail. If you wish, you can find out on the internet, but you just have to write the use. The third is the industrial use. So radioactive isotopes are used for atomic nuclear reactors, okay, to generate electricity and various other uses that you should know.